Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything on your upcoming test, covering measurement, so area, volume, perimeter, and also angles. So let's start with measurement, and let's start by looking at length. So this chart helps you convert between units of length. For example, if you're in meters and you want to go to centimeters, you times by 100. If you're in millimeters and you want to go to centimeters, you divide by 10. So the general rule is if you want to go from a smaller to a larger unit, you divide because there are less of these larger units. And if you want to go from a larger to a smaller unit, you times because there are more of the smaller units. So sometimes you will have to perform these length conversions when calculating area, perimeter, or the like. So let's look at finding the perimeter of this shape here. So this is a rectangle. Now, as I'm sure you know, perimeter is just the length around the outside of the shape. So we're just going to add up each of these sides. The problem is that they're in different units. So I must first change them so they're in the same units. So I'm actually going to change this 1.5 kilometers to meters. Kilometers to meters, I times by 1,000. 1.5 kilometers is the same as 1,500 meters. So now that I have the side lengths in the same units, I can easily calculate the perimeter. So the perimeter, there are two sides that are 1,500 meters plus two sides that are 800 meters. Remember, for a rectangle, opposite sides are always equal. So just putting that in a calculator, if you need to, we get 4,600 meters. That's our final answer. So let's look here at a circle. We don't call the length around the outside of a circle the perimeter, we call it the circumference. The reason for the different name is technically a circle has no sides. So to calculate the circumference or area of a circle, we need to know what the diameter and radius mean. The radius is always half the diameter. The diameter is always a line from one side of the circle to the other going through the middle. The radius just goes from the circumference to the middle. So if I want to find the length around the outside of the circle, called the circumference, I use the formula 2 pi r. You will definitely need your calculator for this because pi is a very, very tricky number. It's like 3.141592653, blah, blah, blah. Decimals go on forever. So the circumference of this shape is just 2 times pi times radius. And putting that in the calculator, you get about 25.13, and this will be in meters because the dimensions were in meters. All right, let's now look at area. So you need to know the area of four shapes: rectangles, triangles, parallelogram, circle. So each of the formulas is written here in red. Note that H, whenever it appears in an area or volume formula, it always means the perpendicular height, not the slant height. Area is just the amount of space that can fit inside a 2D shape. All of these shapes are 2D. They have like width and length, but they don't have depth. So for a rectangle, to find its area, it's just length times width. The area of this rectangle is just 8 times 5, which equals 40. Now always remember to write units. Area is always in square units. Here it's meters squared because dimensions were in meters. So make sure you understand that when finding the area of a rectangle, it's just two numbers multiplied together. A common mistake people make is when they're finding area, they just multiply all the numbers together that they see on the page. So let's look now at a triangle. A triangle is half a rectangle. That's why we divide by 2 for its area. So the area of this triangle will be base, which is 12, times perpendicular height divided by 2, and that equals 30. And again, area is always in square units. So when we're finding the area of a triangle, we don't care about the slant height. H means perpendicular height, perpendicular at 90 degrees. The base and the height here are at 90 degrees to each other. So similarly for a parallelogram, there's a H in there. So we want the perpendicular height, not the slant height. The area of a parallelogram is like that of a triangle, except you don't divide by 2. The area of this parallelogram is base times perpendicular height. Once again, it's going to be units squared in our answer. We want the perpendicular height, not the slant height. So the formula for the area of a circle is pi times radius squared. So here I've actually given you the diameter is 12, so that means the radius will be half that and 6. So it will be pi times radius squared, and you'll get a weird number again. To one decimal place, it's going to be 113.1, and it's going to be meters squared. All right, let's now look at volume. So we can really only calculate the volume of a 3D shape, a shape that has 3 dimensions, length, width, and height or depth. Now, you'll sometimes be asked to calculate the capacity of a shape. So volume and capacity are exactly the same except for units. Volume is measured in cubic units, like centimeters cubed or meters cubed, whereas capacity is measured in units that we typically associate with liquids, like milliliters and liters. This chart helps you convert between units of capacity and units of volume. Now, we're only looking at the volume of rectangular prisms. So rectangular prisms are shapes like this. 3D shapes, they have 6 rectangular faces, 3 you can see, and then there's some obscure ones on the bottom, side, and back. So to find the volume of a rectangular prism, it's really simple. All you do is multiply together the 3 dimensions, length, width, and height. So it doesn't matter which number you call length, which you call width, and which you call height, as long as you multiply them all together. So 8 times 6 times 4 gives you 192. Now the units are in meters cubed. So I want you to have a think about what the capacity of this would be, because we know the volume's 192 meters cubed. A lot of people say, oh cool, yeah, 192 liters. But think about this, 8 by 6 by 4 is massive. That's the size of like a house. So it's going to hold a lot more than 192 meters cubed. If I want to find out how many liters it holds, I use this chart. So I'm in meters cubed now. I want to go to liters, I times by 1,000. So I just go 192 times 1,000. This shape here would hold 192,000 liters. All right, let's now look at doing the opposite, where you get a measurement and have to find a side length. See, in each of the previous examples, I gave you the side lengths and we figured out the area or volume. Now we're going to look at an example of doing the opposite. So when you're given a measurement like an area or volume and you have to find a length, follow these 3 steps of writing the formula, substituting, and then solving. Probably doesn't make a lot of sense now, so let's look at an example. The area of a triangle is 32 centimeters squared, base is 8, what's the perpendicular height? So we're going to start by writing the formula. Because this is about the area of a triangle, we're going to write the area of a triangle formula. So this is just what I gave you on a previous slide. Now we're going to substitute what we know. We're going to change A, the area, to 32. I didn't do any maths there. I was just told A is 32. And we're told that base B is 8. I still don't know the height, so I'm just going to write H. So here we have an equation to solve. Note that 8h divided by 2 is just 4h. 8 divided by 2 is just 4. So I've got 32 equals 4 times h. In other words, whatever the perpendicular height is, when you multiply it by 4, you get 32. So what number do you multiply by 4 to get 32? Well, if you don't know off the top of your head, just do the opposite of what's been done to h. h was times by 4, so we're going to divide by 4. H is just 32 divided by 4. It'll be 8 centimeters because everything else was in centimeters or centimeters squared. So the perpendicular height must be 8 because 8 times 8 divided by 2 gives you 32. All right, let's now move on to angles. So I'm sure you know what an angle is, but what we did this year was we looked at using geometric reasoning. That's where we calculate the size of an angle without measuring, so no protractors needed. So there's heaps of different types of angles you need to know. We're going to start off with these 3. Complementary angles add to 90 degrees. They make a right angle. So these 2 angles here are complementary. They must add to 90 degrees. So if one of them's 32, the other one's just going to be 90 minus 32, which is 58. Now, whenever you're stating the size of an angle, you should write a reason. Of course, during a test, you're under time pressure, so just write something like comp, and I'll know that you mean that x is 58 degrees, and we know that because the angles are complementary. So let's look at these 3 angles here. They're example of supplementary angles, angles that add to 180 degrees. 180 degrees is the angle in a straight line. This angle, and this angle are supplementary. They must add to 180 degrees because 180 degrees is the angle in a straight line. So, of course, to find out x here, they add up to 180, so we can just subtract the 90-degree angle. Make sure you know that this means 90 degrees. And then we can subtract 70, and we are left with 20 degrees. Once again, I need to give a reason. If I just write sup, everyone will know I mean supplementary. So the final type of angle on this slide, angles at a point. They make up a full revolution. So this is the point we're talking about. If you add all three of these angles together, they make a full circle, and a full circle is 360 degrees. So this one's a little bit harder because we've got x in more than one spot. But what we do know is that the 120-degree angle plus the angle marked x plus the angle marked 2x must add up to 360, the reason they're angles at a point. So basically what this is saying is this angle is 120 degrees, this angle we don't know, but this angle is twice as big as this one. So this is an equation that we can solve. Note that x plus 2x is 3x. If you have an x and you add 2x, you now have 3x's. So we have 120 plus 3x gives us 360. So now what we're going to do is undo what's been done to x. We're going to subtract 120 from both sides, and then we're going to divide by 3. Remember, 3x means 3 times x. The way we undo timesing by 3 is to divide by 3. I get x equals 80 degrees. Once again, I write my reason, angles at a point. So this angle's 80, this is 2 times 80, double 80, which is 160, because 160 plus 80 plus 120 gives 360, a full revolution. Now let's look at angles in parallel lines. So firstly, we need to understand what it means for two lines to be parallel. So two lines are parallel if they never meet, never intersect, go forever in the same direction. We can tell lines are parallel by the arrows here, or sometimes we use 2 arrows. So sometimes parallel lines will be cut by another line. This is called a transversal. When a transversal cuts parallel lines, it gives rise to alternate, corresponding, and co-interior angles. We need to know each of them, and we also need to know vertically opposite angles that I'll touch on. So let's first look at alternate angles. So I wrote the Z here because they're characterized by a Z shape. It can also be a back to front Z. So if I draw the line here, we can see enclosed in them are these two angles in red. These two angles are alternate. Alternate angles are always equal. So if this angle's 40, so too this angle's 40. If this angle was 150, this angle here must be 150. So in this diagram, I've marked vertically opposite angles in blue. These two angles here are vertically opposite, and vertically opposite angles are also equal. These two angles are vertically opposite, meaning they're equal. So if this angle here was like 110, so too this would be 110. This angle was 80, this would be 80. You can sort of see that vertically opposite angles make kind of an X shape. It might be an X on its side, but they make the X shape nonetheless. Now, vertically opposite angles are different in that they don't require parallel lines to be equal. Vertically opposite angles are always equal. So the next pair of angles we're going to look at is corresponding angles. They're characterized by an F shape. So if we draw the F shape here, you can see that enclosed in it we have two angles here. They are corresponding. They are also equal. So if this was 120, this would be 120. Of course, just like for the Z shape, the F could be back to front, it could be upside down. So if I draw an upside down F here, it turns out that this angle here and this angle here are also corresponding and also must be equal. The final pair of angles are co-interior angles. Now they're different because they're not necessarily equal. Co-interior angles are marked by a C. Again, it could be a back to front C or an upside down C. These two angles here are co-interior. Turns out also these two would be co-interior. Now, unlike in the other diagrams, I used a different symbol for these angles. That's because co-interior angles are not necessarily equal. They are supplementary, meaning they add to 180. So if this angle here was, say, 100, this angle wouldn't be 100, it must be 80, because they have to add to 180. So we're going to use these facts in geometric reasoning. We're going to get diagrams like this and find the value of angles without actually measuring them. So let's look here and say I have a pair of parallel lines. I'm going to find X, Y, Z, and W. It doesn't really matter the order in which I find them. So let's start with X. What would X be without measuring it? Well, see here, these two are kind of characterized by the X shape. These two angles are vertically opposite, and vertically opposite angles are always equal. So X must also be 83 degrees. We need to write a reason. We can just write vertically opposite, and I'll know what you mean. Okay, let's look at Y. Y is also 83 degrees because these two angles are characterized by the Z shape, even though it's kind of a Z on its side. These two angles here are alternate, so I would just write Y equals 83 degrees as well. The reason is they're alternate. Now it turns out that that 83 degree angle here and the Z angle here are enclosed in a C. There's kind of the C shape there. These two angles are co-interior. So remember, co-interior angles are not necessarily equal. They're almost always not equal. They add to 180. So if this is 83, Z would be 180 minus 83, which would be 97 degrees. And once again, whenever I state the value of an angle, I need to give a reason why. So finally, let's look at W. So you've probably guessed that these two angles are corresponding. They're enclosed by the F shape here. So this angle and this angle are corresponding. We know that corresponding angles are equal. So W must be 83 degrees. And we just write our reason. We can just abbreviate it because I'll know what you mean. All right, the final thing we need to do is the opposite of this. So this is the opposite because in the previous slide, I told you the lines were parallel and asked you to find the size of angles. Here I'm going to tell you the size of angles and you have to tell me whether or not the lines are parallel. Now, you can't just look at the lines and say, oh yeah, they look like they're going in the same direction. You have to use proper geometric reasoning. So, if you conclude lines are parallel, you need to use one of the following reasons. You need to find a pair of alternate angles that are equal, a pair of corresponding angles that are equal, or a pair of co-interior angles that add to 180. If you want to conclude that two lines are not parallel, you need to find two alternate angles that are not equal, two corresponding angles that are not equal, or two co-interior angles that do not add to 180. So these are the kind of questions you'll get. So here we're asked if there is a pair of parallel lines. Well, obviously this transversal here can't be parallel to the other two because it intersects it. I'm asking, is this line and this line parallel? So we need to go on the hunt for alternate co-interior or corresponding angles. So note that these two angles here are actually co-interior, characterized by the C shape. So we know that co-interior angles should add to 180. Now 95 plus 85 is 180. So here we have two co-interior angles that are supplementary that add to 180 degrees, so therefore the lines will be parallel. So this example over here is a little more difficult. These two angles are neither corresponding, nor alternate, nor co-interior. So it's a bit hard. What we do in these situations where we don't have alternate, corresponding, or co-interior angles is we look to see if we can find any other angles. So note this angle here and this angle here are vertically opposite. Vertically opposite angles are always equal. So I'm going to say this is 68 degrees and I need to give a reason. See, the thing is, vertically opposite angles are equal regardless of whether or not these two lines are parallel. Doesn't matter about parallel lines. Whereas alternate angles, corresponding angles, they're only equal if the lines are parallel. Co-interior angles only add to 180 if the lines are parallel. But vertically opposite angles are always equal regardless of whether or not the lines are parallel. So now you can see that we have two angles here that are corresponding. Corresponding angles are supposed to be equal. So because we found a pair of angles that are corresponding but not equal, these two lines must not be parallel. Alright, sorry for the long video, but thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.